All right, so we are jumping into our page of notes where we are going to start looking at transformations on sine and cosine functions. So this should look pretty familiar to you. It's all the same variables, I guess I guess we'll call them constants because they are numbers when we put them into a function. A, B, H, and K. So the BHAK process that we talked about so much earlier in the year, where B affects the horizontal stretch and shrink. H represents the shift left and right. A represents the vertical stretch or shrink. And K impacts the vertical shift up or down. So it's the same things that we've been looking at a lot more early in the year. So hopefully, you guys took what you needed to away from those earlier lessons where we graphed log functions and exponential functions and quadratic functions, and really everything we've studied graphically can all be based on this BHAK series of transformations. One big thing to remember for this unit, just like all your graphing, is that this B value has to be factored out. All right, the X term here in the parentheses has to have a coefficient of a positive 1. Okay, they're going to have some different names because of the nature of trig functions. They're periodic, meaning it repeats over and over and over and over and over and over again. So some of the terms are going to be a little different. They may behave a little bit differently, but it's the same basic ideas. So let's define them. B is the frequency. So we're used to calling that a horizontal stretch or shrink. It's the same thing, but we use the term frequency. So it's basically saying how many cycles does the graph make over 2 pi, right? We're used to our unit circle. We know after 2 pi around the circle, that's how long it takes for the graph to make kind of one full revolution, and then it gets back to where it started from. So in our BHAK, the B is the frequency. It's how many cycles does the graph make by 2 pi. So if we think back to our old rules, when the B is 1/2, it basically means it's a horizontal stretch times 2, right? This is where we think about the reciprocal. So a horizontal stretch times 2. So we would expect this graph to kind of get wider. An easier way to think about it in terms of these periodic trig functions is how many cycles does the graph make over that usual 2 pi. So it usually makes one cycle in 2 pi. When the B is 1/2, it makes half of a cycle by 2 pi. So if I'm thinking about a sine graph, all right, let me get the good old magic pen out here. So instead of it completing one full cycle by 2 pi, when the frequency is 1/2, it only completes half a cycle by 2 pi. So therefore, we can do a little bit of math, and we know it would make the full cycle by 4 pi. And there you can see there's the fact that it gets twice as wide. All right, so B, frequency, how many cycles does the graph make by 2 pi? Even a little easier way to think about it is the period. This is what we're going to rely on when we're doing our graphing. It's the horizontal distance it takes to complete one full cycle. All right, so if our B value is 1/2, we know that it's going to make it twice as wide. It's going to, stretch that graph out a little bit. But a really easier way to think about it is to think of it as to use the period. So if the B is 1/2, our formula for period 2 pi over B, which we can see equals 4 pi. And that is a little bit easier way when we're just strictly doing our graphing to see how long it takes to make one full cycle of this graph. So if we're thinking about this on the unit circle, to go back to like the values that we memorized, when we have this horizontal stretch of 1/2, everything's happening kind of half as quickly. So instead of 2 pi all the way around the circle, it's going to be 4 pi. So we're going to use that to our advantage when we're graphing. H is our shift left or right. We used to think of it as a translation. But since these graphs repeat themselves over and over and over and over again, there's not really an official starting point. So if you look at what I did up here, there's not really an official starting point or an end point. So instead of calling it a translation, we just think of it as a phase shift. So maybe the graph would start here instead. All right, so that's a little vocabulary word you're going to need to get used to. But it behaves the same way. A is the amplitude. We're used to thinking about that as the vertical stretch or shrink, but really it's just how far away we are from that halfway point of the graph. So like, let's say this is the halfway point. Usually we're used to seeing it on the x-axis, but if there's a shift up or down, we'll talk about that in a second, it behaves the same way. It would just, that x-axis would not be the middle line anymore. So the midline can change. So like amplitude, that's not great actually, close enough. If I increase the amplitude, it would get stretched farther away from the midline. So not necessarily the x-axis, but it would get stretched farther away from wherever the halfway line of that graph is. All right, so put a little pin in that. We'll get to that next time I see it. And then we have our reflections like usual. So we can certainly reflect a sine or cosine graph over the x-axis. And just like always, that's kind of what I just mentioned. The K is the vertical shift up or down. All right, so that x-axis where we're used to seeing the middle of our graph, you know, if there's the x-axis, there's my sine function, we can always shift up a couple units and then the graph would kind of look like this, just like any other vertical shift. All right, and we're going to get a ton of practice for this next class. One thing that always helps me is to think, where is my cycle? One cycle of this graph, one full period. Where is it starting and where is it ending? So to think about this, there's two factors that come into play. It's our shift left or right. So our horizontal shift, our phase shift. So that kind of determines where one nice clean cycle of this graph would start. And then where it ends is one period later. So it kind of gives us a nice clean starting point. Where does the graph start? So think about the shift left or right. And then where does it end? So we add on one period to our starting point. Okay, let's do one example. We'll get to a bunch in class. So we did this, we kind of looked at the different, how the B value affects our graphs. I think we should have had time to get to this last class. If not, we'll do it next time. You know what, if we didn't have time to do this, why don't you guys try this on your own? All right, so if we didn't do this in class, you can kind of take a look at my notes here. Try to graph these on your own, but you can see each of these have a different B value. So the B is 1, B is 2, B is 1/2, B is 1/3. So that's what we just talked about as the frequency of the graph, 1, 2, 1/2, or 1/3. And then what really helps us graph it is finding the period. All right, so why don't you pause, and if we did not get to this, you can take a look at my picture, so you can pause here when you're ready to check, but try that out. And if we did get to it, obviously you're good. So let's graph this. So these are the things that we always want to think about when we're graphing a trig function. So 4 cosine 3x. There's not a lot going on here, but we do have an A value of 4 and a B value of 3. So let's think about what those are in relation to our graph. Amplitude is that A value. So our amplitude for this graph is 4. It's going 4 units up and 4 units down from the midline. The frequency is 3. So it's going to basically complete 3 cycles of this graph by 2 pi. So it's a horizontal shrink of 1/3. So it's getting kind of 1/3 as fast, 1/3 as frequent. The period, this is what really helps us here. The period, the formula we define that is 2 pi over b. In this case, our b is 3. So the period is 2 pi over 3. That's how long it takes to complete one full cycle. So if we're relating this back to the unit circle, I know this isn't on your notes. So instead of this being 2 pi, this is going to be 2 pi over 3. So if I cut that in half, it becomes 2 pi over 6 or 1 pi over 3. So that's where it completes half of our cycle. We cut that in half, it becomes pi over 6. So really, if you look at my important points, my quadrantal values, I have kind of 0, We have 1 pi over 6, 2 pi over 6, 3 pi over 6, aka pi over 2, and then 4 pi over 6, or 2 pi over 3. So I can kind of use my unit circle to break this up into our quadrantals, and I'm actually going to talk about that in a second. Phase shift, there is no h value. There's no, if it was like x minus pi over 2, for example, that would be a phase shift, like if it was in parentheses like this, but there's not, so we don't have to worry about it. My interval, this is where I was talking about it being kind of helpful to see where one cycle of this graph happens. So interval, there's no phase shift left or right. So I know my cosine graph is going to start right at 0, and 1 period later, it's going to be over. So in this case, it's just, clear. We start at 0. The cycle is going to end at 2 pi over 3. The quadrantals. So where do those zeros, the ones, the negative ones, where do those easy points happen? So to do that, you can either like think about what I did on the unit circle, or what we'll do is we'll just take our period and we'll chop it up into 4 equal pieces. So 2 pi over 3 divided by 4 is 2 pi over 12, which we can reduce down to pi over 6. And that, as you can see, matches up to what I have on my unit circle. So every pi over 6 is where this cosine graph is going to hit one of those zeros, ones, or negative ones. And there's no vertical shift. So this amplitude, you can kind of think about that as like the radius of our circle. Okay, so I guess I'll mark that in. So this point here, that stretch is, I'm not going to write that. I don't like that. I'm going to come back to something like that later. All right, so anyway, my amplitude is 4. So on my graph, it's going to go up 4 units from the midline and down 4 units from the midline. That's going to be the height, the amplitude, the vertical stretch of my cosine graph. The quadrantal angles, the important values I need to plot are every pi over 6. So that's exactly what I'm going to put on my scale. So I'm not super picky. I don't need you to have this like perfectly scaled out to have everything match up. We'll investigate that a little bit more next class. But I'm going to put the points that I know I need to plot on my graph. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6. You can see I'm doing the reducing in my head. 4 pi over 6, and then we can just keep going. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, and if you want to keep these in terms of 6, you can. 10 pi over 6, and we can keep going. So now we kind of have everything we need. We have our scaling. We know when one shift is going to start and end. One cycle is going to start and end. So here's how we can use our unit circle. The cosine graph. The cosine is the x coordinate. All right, well, yeah, you know what? Let's go back to this. So since we have this stretch of 4, I know these quadrantal values are going to be affected by that. All right, so we're going to use this to our advantage. So cosine graph, the cosine is the x coordinate. So at 0, the cosine value, the x value, is way up here at 4. So remember, a sine graph starts here because the y value is 0 at the origin. Cosine graph starts here. At pi over 6, we're back down to 0. Pi over 3, my x value is negative 4. Pi over 2, my third quadrantal, we're back to 0. My last quadrantal value, we're back to where we started, and that looks like it makes sense. This is one full cycle. It went from 0 to 2 pi over 3. And I'm working on my tablet, so it's going to be a little hard for me to make a pretty graph here, actually. Oh, I almost had it. That's not bad. I want to make it perfect, though. Let's see. Last chance. So you can see how I kind of change my concavity, and then I turn out this way. That's pretty good. Okay, and then we can just continue the pattern. If this is going to go on forever, right? So I can go 5 pi over 6, back to 0. 6 pi over 6, there's my minimum. Back to 0. Back to my maximum. Back to 0. And we can just bring this thing on and on and on forever. All right, notice how I'm making nice smooth turns. I'm trying to, at least at my mins and maxes. I'm not making it like a point, like an absolute value graph. But that's my thought process when I'm going through these. All right, so we're going to do a ton of practice next class. I hope that made sense. I'll see you guys next time. Get the homework check done. Bye.